Hey guys, this is a review video for 4.3 to 4.5 and it's going to go over binomial distribution, normal distribution, and geometric distribution. So first off is binomial. Usually we're going to describe it using bins, and also we need to talk about the center, the spread, and the shape. So in this scenario, it says a certain NBA basketball player is an 85% free throw shooter, meaning he has a 85% probability of making any given free throws. In 1 month, he will shoot 100 free throws, assume each shot is independent of the other, and we're going to let the variable x equals the number of free throws he makes out of 100 attempts. So using bins, first we have is B, which represents binary, and that just shows us that we have either a success or a failure. In terms of our success and failure, we do have making it and missing our free throw shot. So I'm going to say two outcomes, and they are either make or miss. Secondly, we have is I for independent, and we were told that the shots were independent of each other, so I'm just going to write that down. And then N stands for fixed number of trials, which they shot 100 of them. And then S is for the probability of succeeding. So it says that the probability of succeeding is 85% that this person will make his free throw shot. Okay, so that's first part, just letting our readers know that it's binary, and then we're going to go to center, spread, and shape. And the center and the spread can actually be found in your formula sheet. So if you take a look at your formula sheet under number 2, section number 2, probability and distribution, you'll see that the mean for binomial is n times p, and the standard deviation is the square root of n times p times 1 minus p. So to denote that, I'm going to do mu of x is equals to n times p, which is just 100 times 0.85, and then you guys can calculate that on your own. The spread is going to be denoted as sigma x, which is the square root of n times p times 1 minus p. And if I were to plug in the values, it's going to look something like this. As for the shape, typically the shape is going to be approximately normal. However, we need to test that, and the only way to test it in this type of problem is to use n times p and making sure that it's greater than 10, as well as n times 1 minus p is greater than or equal to 10. Eventually, you're going to find out that both of these work, so we're going to imply that this distribution is approximately normal. Okay, so that's going to help us with that part of it. So totally use the formula sheet here. And then moving on is, what is the probability that the basketball player makes exactly 8 free throws out of 100? So to denote that, I'm going to say the probability that x is equal to 80. Whenever something is exactly 80 or equal to 80, we're going to use one of the two, either PDF or CDF. But if you take a look at our exam tip, if we're looking for exactly, we're going to use PDF. So I'm going to go to binom, PDF, and then I'm going to make sure that I label every single piece that I plug in here. And then I've got 100, 0.85, and 80. And then you guys can calculate the answers by going into your calculator. Go to second, vars. Distribution is the first section that you see, and then you're going to go down till you see binomial PDF. And then for part C, it says find the probability that the player makes at least 80. So that means like 80, 81, 82 free throws out of 100. So we know the probability that x is greater than or equal to 80 is equal to binomial, and then we're going to use CDF for this one. And I'm going to do N, P, and then K. But notice it also says greater than. Binomial CDF and PDF, or binomial CDF specifically, only reads our diagram to the left. So I got to do 1 minus, or I mean read the number line like all the numbers below. So any number below 80, binomial CDF will read. So if it can only read below, I have to do 1 minus for it to read above. And then I also have to think about, am I going to do k? Am I going to put 80 in there, or am I going to do 80 minus 1, which is 79? So for this problem, it still remains 100.85, and I'm going to put 79 because I want, like, if all my numbers is out of 100, I don't want any numbers that is 79 and below, which this will represent. So if I take 1 away from all these numbers, I can get any number above 80. So draw out a number line to help you with that if that is the best for you. Okay, so go ahead and calculate all this so that you can feel a little bit better about the calculator. And then for exam tips, just make sure that you check out the formula sheet and know where to find center and spread. And it is in section 2. Okay, moving on is review 4.4, which is normal distribution calculation, and you guys should be proficient at this at the moment. The example here today is the number of daily views at statsmedic.com follows an approximately normal distribution with a mean of 15,000 and a standard deviation of 4,000. So find the probability that a random selected day has more than 20,000 views. So typically in our normal distribution, we have to label our mean, which is 15K, and a standard deviation of 4K. So I'm also going to put the mean here. And then I need to shade. So this helps writing the mean down because then I know that 20K would be above. I also have to shade above. So this is 20K. Okay, so then I'm going to go to my test statistics because that's going to help me find my p-value / my probability. So my test statistics ideally is this formula, which translate to z equals x bar minus mu over our standard deviation. Values that I'm going to plug in is 20K minus 15K over 4,000K. 5K over 4K is 1.25. So I'm going to go into my z-score table, which has been a while since we used table A, and then I'm going to go to 1.25. So it's going to be moving down a little bit more right here. So I have 0.8944 is my p-value. But just also notice that minus because it is greater than. This is 0.1056. So I'm going to end this off with a short sentence like the probability that the randomly selected day has more than 20,000 views is approximately 11%. Okay, so that's something additional that you also want to add. As for part B, it says how many views would it be in the bottom 5% of all days. So I know this is 15K still, and then this is 4K, and their goal is to look for the bottom 5%. So we know that inside our table is 0.05, and we basically need to figure out how many days is that. So we're looking at it in terms of days at the moment. So what we're going to do is kind of go a little bit backwards to figure out our answer here. So what you want to do is you want to find the z-score first that associates with this problem. So if I look at 0.05, the z-score that associate with this problem would need to be found inside here. So not going to be on this page, probably on this page, but 0.05 is maybe somewhere, I think between here. These are pretty good numbers to use. So somewhat in the middle of those two. So I'll do 0.045, negative 1.645. Okay, so that's my z-score. So I have to basically work backwards in order to get whatever my x bar is potentially. So my z-score is negative 1.645 equals x bar minus my mu of 15K over my standard deviation of 4K. And my goal is to move everything around in order to get x by itself. This is a multiplication symbol. So once I do that, you start moving everything around. You'll eventually get your x bar is equal to 84 or 8,420 days. Okay, so AP exam tip for today is just make sure that you label your picture, and then also show your specific formula. And your specific formula here is going to be this formula right here. Okay, if you don't end up doing general, it's okay, but as long as you do specific. All right, last question for this review is geometric distributions. Geometric distribution also has to deal with bins. And then we are also going to look at the center spread and shape first. So in this example, it says in 2016, the bottle flip challenge, which is when you flip a water bottle in the air and landing it right side up, took the internet by storm, as you guys probably recall. Michael is really good at the bottle flipping. On any given bottle flip, he has a 35% probability of landing the bottle right side up, assuming that each bottle flip is independent. Let x equal the number of flips it takes until, keyword here, Michael lands a bottle flip. So conditions we have here is binary. We know that we have two outcomes, and either he's going to land or not land. In terms of independent, we know that it was told that it's independent. And then the number of fixed trials, we don't have the number of fixed trials. So we actually have the number till our first success. So we're using the word until here. So I'm gonna just say not fixed, which is fine. And then our probability of success is 0.35, okay? In terms of describing our distribution, we have our formula sheets. And if you look at section 2, notice that you see geometric, and then you'll see this, and you'll see this, which represents the mean and standard deviation. Okay, so in terms of our center, it says that the mu of x is equal to 1 over p. So technically I'm doing 1 over 0.35 and calculate that out to see whatever it is. In terms of our spread, the standard deviation of our x is equal to the square root of 1 minus p over p. And if I were to plug in values, technically 1 minus 0.35 over 0.35. So that's going to get you a value, which is totally easy to do. And then for this one specifically, for a geometric distribution, it is always right skewed. So right skewed is going to look something like that. Okay, and then part B, it says find the probability that it takes Michael 4 flips until he lands the bottle right side up. So if you guys go back to the formula sheet and then you take a look a little bit closer, you will see that there is a formula right here where you can utilize. So I will write that formula down. Maybe I'll write it in the exam tip actually. That'll be useful. Okay, so I have the probability that x equals, I'll put k here. So k right here will represent the 4 flips. And it's going to equal to 1 minus p times k, or to the k minus 1 times p. So if I were to apply this formula, it's going to look something like this. So basically, as an explanation, I want this to fail 3 times because on the 4th time, I want it to succeed. So that's basically all that means. And then next is find the probability that Michael lands the bottle right side up within the first 4 flip. So when I do this problem, this problem is going to look something like this. Okay, so it can be on the fourth flip or anything less than the fourth flip. So what I want to happen is that I want it to succeed. Like, I gotta find how many times it will succeed at least once, how many times it will succeed twice, or on the second try, and then on the third try, as well as on the fourth try. So I have to find the probability of all of these. So what this technically means is if I want it to succeed one time, what's the chances of it succeeding on the first time? That's just technically 0.35. And that's technically 0.35 to the first power. If I want it to succeed on the second flip, but not the first, which is going to represent the second term, I want it to fail on the first time, but then on the second time, I want it to succeed. And then continuing forward, I want it to fail at least 2 times first so that on the third time it could land. And then on the fourth time, let me move all this over actually. No more space. Okay, that's what happens, whatever. Okay, and then on the fourth time, I'm gonna do 6.65 to the third, and then times 0.35. So this was a little extensive. As you can see, I had to write every single piece down, but instead of doing this, obviously there is another way, and this other way is going to be based off of the calculator. So instead, I could have just done geometric CDF because it's reading less than, and I'm doing geometric distribution, and inside I'm gonna put the probability of success, which is 0.35, and then the last number that I'm looking for, which is on the first 4. Okay, so if this doesn't say equal to 4, then I'm gonna put 3, but because this says equal to 4, I'm gonna put that. And then you always want to label what each of these values are. So I'm gonna label this as probability of success, and then I'm gonna label this as n. To find it in your calculator, it's the same area as where you'll find binom, which is second vars, and then distribution, and then just go down until you see geometric CDF. Okay, so that's how you are going to calculate that. But hopefully these 3 videos had help. That is pretty much it for this lesson review.